Yannick Edwards, this is Amadou, and Kimmy. Our robot project was basically we're going to take two robots and allow one to drop a ball through the bridge and catch it with the other one to show how precise we could program a robot to do certain tasks. So our directives. Learning how to use the software was the first part. It was pretty challenging, especially having to figure out which buttons make the robot do what. And if we switch a robot, then it's a whole nother different process you have to relearn. Next. Programming the robot to do a series of tests was interesting because you have to constantly adapt the materials that you're using because the robot is limited to certain motions. And if you don't calibrate the robot properly, you could end up making a mess of your project. Next. The obstacles, measurements. Everything had to be measured from the distance of the robot to the bridge, to the cups that we're holding, to the way we wanted to rotate the hand over a specific area to make sure the ball drops in the right place. Next. Of course, you have to record your data. Procedures. Well, first after finding the materials, our procedures pretty much was, judge the distances of the robots to the ball, plot up how we want the ball to roll, use other materials that we had to angle the bridge at the proper way to make sure the ball rolls into the cup the way we wanted it to. One of the major issues we had was the cups. They wouldn't stay in place. Sometimes the hinge of the cup we were using can be too strong. If it was too strong, it wouldn't fall in the proper place. If it was too weak, the ball went everywhere.
Yeah, that part was hard.
Yeah. Next. Who's up?
Okay, this is the prototype. We use a bridge, and also we measure the distance between the bridge and robo number 1, and also we measure the distance between robo 2, robo 8, and the bridge. We also design pretty much we just design like putting like one cup here, like the ball here. So it's gonna take this ball and throw it here, and then robo number 8 gonna catch the ball. So this is how we put it.
The
Overlook, so you can see the bridge, how it's gonna slide from here to over there.
And finally, discussion.
First of all, we look up from our mind what you're gonna do on our bridge. Like we came up with like let's do like bridge, and then we gonna put the ball and slide and all of those stuff. And then we make sure we found a right angle, stuff like that. And also we design like how we're gonna catch the ball, all of those stuff.
Yeah. And finally, highlights. So what makes our project different? We use the two robots and we taught them to work together and cooperate with each other. And that's a picture of President Obama working together with his wife, just like the two robots working together. We worked very hard on timing the two robots. The robots wait for each other until they both get to the right position and then continue the whole process. And we ran the two robots at the same time and kept the timing, the ball, and many other factors all under our control. So that was our. And finally, for conclusion, robots are made to do what humans either cannot or do not want to do. That's a picture. Humans sometimes are very lazy now. And the robots are not meant to make things harder or fancier, but to make things easier. The think principle has been used in many ways in our life now. 3 of them I can think: vending machine, toy machine, an excavator. So it's interesting that if you take a close look at the machine and the robot, the format and the way they're working is very, very similar. Yeah. And finally, that's it. Thank you very much and enjoy the pictures.
You guys have questions?
I'm so listening.
What's up with those pictures?
Just enjoying.
Yeah, that's just for fun. Don't take it serious. Yeah, go ahead.
Okay. Okay, thank you so much. Yeah. Group one. Yeah, it looked like you guys were enjoying the presentation
Yeah,
time.
very much.
Yeah, but my question is, how does the macros work?
What?
The
The
one.
macros, the task of the business, of your robot.
The macro.
What was the actual task, the macros? If you are able to run the machines, you're able to know the word macros. How does it work?
We don't really understand your question.
I don't know what is macro.
Nah, I think what he's saying is like
It's a block.
how does
Script.
the program run the script to do the function, right?
Thank you, that could be part of
Really?
it. How
This
does
is
it work?
That's C++.
We know our objective already, right?
I think we mentioned that during the objective and procedure, so we just make sure we program our robot so we can do other tasks. That's what we say. Thank you. Good job.
Good job. Another
We're gonna